Okay, so hi and welcome. Can you hear me?
Yes, hello.
Yeah, so how are you?
Good, how are you?
Fine. Okay, so I simply share my screen and then show you all of the things one by one. I hope you can easily learn all of those details as well as you can apply and also complete our all of the stuffs. Okay,
Okay.
can you see my screen now?
Yes.
So basically today we talk about that NDVI, how we can easily make
Mm-hmm.
the NDVI map as well as how we can easily make the change detection map of NDVI using Google Earth Engine
Yes.
platform, as well as we can calculate it that how much area will be increasing of vegetation or how much area will be decreasing of the vegetation. Okay, so this type of things I try to complete. So first of
Okay.
all, here you can see this is our content. So basically, we talk about the multi-year NDVI, so different time period of NDVI, such as 1987, 1997, 2007, 2017, and 2023. This is our time frame about that annual NDVI. We just try to calculate from here, as well as also
Mm-hmm.
land surface temperature. Okay, suppose a multi-year land surface temperature, such as 1987, 1987, 2007, 2017, and 2023. Okay, we also calculated the LST, and we also try to make the change detection of multi-year NDVI and LST. Okay, so let's
Okay.
go one by one. We try to talk about all of those things. And first of all,
Mm-hmm.
NDVI. Okay, so today I will discuss about only for the NDVI. So further other
Okay.
class we talk about that LST. Then other class talk
Mm-hmm.
about the change detection. Okay, one by one we try to complete all of those things. Okay. So first of all, NDVI mainly it's the vegetation index. Okay. So and this is the formula about the NDVI, near minus red divided by near plus red band. Okay. And we are using the different types of pixel or thresholding. Okay. Suppose you can see the range of NDVI value -1. Okay. So all of those negative pixel value -1 in this time we consider as a water body. So basically negative pixel value it's provide our the water body. Okay, and such as it also show about the zero. Okay, only for the zero pixel value
Yeah.
we can get the barren soil, rock, sand, snow, and cloud also. And mainly vegetation will be start count from the zero point 0.2 and to 0.3. Okay, vegetation start from here 0.2 to 0.3. So basically, it's the sparse vegetation such as the grassland or shrub, and 0.3 to 0.5 we can get the some unhealthy forest or sparse vegetation, and greater than 0.5, greater than 0.5, all of those vegetation mainly it's the dense vegetation or healthy vegetation. Okay, so for the NDVI we can get the range of vegetation. It will be start from the 0.2. Okay, in the NDVI pixel value when it across the 0.2, then it will start from the vegetation. So 0.2 from 0.3. So mainly in this range we can get the shrub and grassland. 0.3 to 0.5, this range we can get the sparse and unhealthy forest, and greater than 0.5, all time we can get the dense vegetation or healthy vegetation. So according to this range, we can divide it this type of classes of vegetation covered, such as you can see 0.2 to 0.3, we consider it's a low vegetation. Okay, 0.3 to 0.4, it is the medium, and high 0.4, all of those pixels we can as the high vegetation. So in this time, according to this range, we just classify our NDVI value low, medium, and high. And then further, we calculated the area. So basically, it is another research paper work. Calculated the area, suppose how 0.2, 0.3, how much area? Okay. 0.3 to 0.4, how much area? 0. High, greater than all of the 0.4, how much area? Okay. And also calculated the percentage. Okay. And also calculated for that, you can see the 2014 and 1990 and 2014, and then make the change between how much it will be increasing or decreasing. You can calculate from here. Okay.
Yeah.
So in this time, we talk about that how we can easily do this type of analysis using Google Earth Engine platform. Okay. So I simply open my code editor and try to show all of the things one by one. So just I open my code editor. And in this time, our region of interest is Qatar, whole country boundary of Qatar.
Yes.
So first of all, I need to import the boundary shape file of Qatar. In Google Earth Engine platform, we can easily access all of those country boundary polygon or shape file easily. We can easily find out. So for that, you can see this is the code top of the code editor search bar. Simply search here US DOS. Okay. So you can simply search here US DOS. So here you can see this is the large scale international boundary polygon. Okay. Simply click on here. So now it provides you all of those country boundary shape, polygon or shape file. So here I can easily get the Qatar boundary also. So just I simply import. You can see the import button. Click on the import.
Yes.
So now I import that. In this time, it is a table. Table is a variable name. It is a default variable name as a table. If you want, you can change it. Or if you don't change it, there is the no problem. Okay. So in this time, this is a variable name table. And this variable stored the all of those country boundary polygon. Okay, this variable stored the all of those country boundary polygon. So now I just need to filter only for my country of Qatar. Okay.
Yeah.
So for that, just take a variable. You can import the variable name, put here the var keyword, and then put the variable name. You can put any variable name, any. Suppose I put the variable name is the ROI. Okay, you can put any name. Then put the equal sign. So then you can see the table. So this is my data set. This data set stored all of those country boundary polygon. So now this data set I need to filter. So just I simply call the table and paste here. And now I want to filter it. So use here the filter function. Okay. And now in this parenthesis, I need to define how I can filter. So basically this is the table. It stored my all of those country boundary polygon. So now this data set I need to filter. Then how I can filter? I define it. I want to filter Earth Engine. EE means Earth Engine filter dot EQ. EQ means equal. So Earth Engine filter equal. So now what's equal what? I put here. What's equal what? So for this information, I can got from here. Simply click on here the data set of my shape file. So here I can see, you can see table of schema. So in this time, I can set here the country code or country name, anyone. So suppose country name, country NA. Simply copy this and then paste here. And then set the country name, Qatar. Okay. So now what happened, you can see, this is my table. This variable stored all of those country boundary polygon. This data set I filter. So use the filter function. And how I can filter? I want to filter where country name equal Qatar.
I see.
Okay. So now this Qatar boundary shape file is stored in this variable ROI. So now add a layer. So basically in this time, this is a map. This map I want to add a layer. So that's why I need to use a function map dot add layer function. Okay. Because this is a map, this is my map, and this map I want to add a layer. So use the map dot add layer function. And now I want to add the layer of Qatar. Okay. And Qatar is already stored in this variable ROI. So I simply copy that and paste here. Another thing don't need, I simply remove that, it's not need. Okay. So now click to the run. In this time you can see one layer is added, but it's not focus the center of the Qatar. It show the United States. So in this time, I need to focus the center of the Qatar. So that's why in this time use at the map dot center.
Here there is a message told me line 1 cannot read probably EQ.
Okay, EQ means equal.
Yeah.
Okay, so in this time you can see what happened. So this is my data set table. Okay, this table is storing all of those country boundary polygon. Okay, and now
Yeah.
this data set I need to filter. Okay, so I simply call the variable name table and use at the filter. And how I can filter? Art engine filter equal. Okay, so art engine art engine filter eq means equal. So in this time I want to filter country name equal Qatar. Okay,
Yeah.
so in this time this Qatar boundary shape file is stored in the ROI. So I want to add a layer of the ROI, and in this time I just focus the center of the ROI. So use at the ROI. Okay, click to the run. So in this time it directly focus. Let me check about the what is the spelling of the Qatar.
QATAR. Right.
Okay, okay, so okay. So that's why I mistaken here. You can see I put the wrong spelling. That's why it's not working. Okay, so now it worked. Great. Yeah. So we have to use at the correct spelling. Then we can get the. So this is my study area. So now this study area, I just make the NDVI map. So according to my multi-year, such as 1987, all of this year, I need to make the generate the annual NDVI map. So I can get my boundary. So first of all, suppose one by one, we just generate all of those multi-year NDVI map. So for that, suppose first of all, 2020 or 23. Okay. So basically it's a comment. So when I use this type of symbol and write anything, it's just a comment about that. Okay. So I put the comment, suppose NDVI 2000, okay, 2023. So in this time, I need to.
There is a message. There is a message for me. They told me cannot read. Why?
Why? Where?
Can I share my screen?
Yeah, please share. I also check. In this time, you also practice. There is no problem. Yeah, kindly share. I think you also check about the spelling about the Qatar. Or share the screen. I check and then find out the problem.
Can you see now?
Okay, in this time you make the mistake. EE dot filter. EE dot filter. This F is the uppercase, not lowercase. Okay.
The filter, the F here. I see.
Not okay, not here. So table filter. Okay, you can see my screen again. You can see I simply shared, then it will be okay. So you put the wrong code in here, so that's why it's not working.
Can I see? Yeah, please.
So here you can see, first of all table, okay, then filter, FILTER. You can see. After you can just simply use the parenthesis and use e dot filter dot equal. Then country name keyword. Just use the same way, okay. Simply call the table, then put the filter dot filter. Then put the parenthesis dot filter. F is the uppercase, okay. Then EQ. Then put this type of things.
Can you see my screen?
Okay, so it show very small, so just stopping the showing. Okay, so now it show very small. So you can write
No.
yeah. Okay. So now okay. So okay. So in this time, table dot filter. This F is the lowercase. Okay. Table dot filter. This F is the lowercase. Yeah. So now it's okay. Click to the run. It will be working. And map dot center object. O is the uppercase. Yeah, you can see. Okay. So it's a camel case. One is the lowercase, then uppercase. Camel case we can use in here for the syntax.
Yeah, it's working now.
Yeah, so now you can get the boundary of the Qatar. Okay, so now let's go and to the further process. And you can also get the recorded video class also. There is no problem. You also try to for later watching the recorded video class very carefully. Then you
thank you very much. Okay.
okay. So now here I can get the ROI. So now I need to calculate it the NDVI. So for that, what can I need? I need the Landsat image of 8, Landsat 8 satellite imagery. So for that, what can I do? You can see here the search place. You can see the browse data catalog. Click on here. It open a new window. Here I can get, you can see the Landsat. Okay. So click on the Landsat. So now I can get all of those Landsat image collection. You can see all of those Landsat image collection. Okay. So in this time I use here the Landsat 8. So click on here. And here I can get different types of sensor, surface reflectance, top of atmospheric, raw image. So basically NDVI or other types of indices, the top of atmosphere, this image collection we are used for the identify for the NDVI or other types of index. Okay. So here you can say I can get the image collection look like that. And here you can see the data set availability. We can get the data from year of 2020, year of 2013 to 2023, November 13. Okay, so this is the last time about that. So according this time we can get the data set, and this is the data set provider, and this is the unique ID Art Engine Snippet. So basically this is the unique ID of this data set. So now I just need to filter this data set. Okay, so how I can filter? Very easy. First of all, this data set you need to import in your code editor. Okay, so this is my code editor and this is my data set, Landsat. So now this data set I need to import. So how I can import? Very easy. Just simply copy this snippet. Simply copy.
Can you tell me from where I go here, the catalog?
Okay, so you can simply click on here, browse data catalog. Okay, click and then open a new window. You can see the Landsat. Okay, click on the Landsat, and here you can see the Landsat 8. Okay, click on the Landsat 8, and further we can get the different types of surface reflectance, top of atmospheric. Click on the top of atmospheric. Okay, because in this time we are using at the top of atmospheric reflectance image to create the NDVI.
Yes.
Okay, so now you can see the this type of information, dataset availability, dataset provider. You can see the Art Engine Snippet. Okay, so in this time I need to import the dataset in my code editor. So very easy, just simply copy this snippet. Okay, so basically this is the unique ID of your dataset. Okay, simply copy from here, copy and paste on the paste in here. Okay, simply paste. And now give a variable name. Just give a variable name. Before the variable name, must use the var keyword all time, and then put a name. You can put any name. Suppose I put the name is the suppose Landsat 8. Okay, you can put any name. Okay, so now this is my image collection, and now this image collection is stored in this variable Landsat 8. So now this Landsat 8 image collection I need to filter. So how I can filter? Very easy. Just first of all, you need to define where you, it's a comment, okay, where you need this image. Okay, so you need to define it where you need this image. You need this image in the Qatar. Okay,
yes,
and Qatar is already stored in the ROI. Okay, in this time you can simply use a function, this function called filter bounds function. Okay, so mainly this filter bounds function define your boundary. Okay, so where you need this image, filter bounds. So filter bounds function define your boundary, and your boundary is the Qatar. So it's a Qatar, and Qatar already stored it in a variable ROI. Okay, simply use here the ROI. Just write here the ROI I need this image in the Qatar, so I put here the ROI because ROI stored the Qatar boundary. Okay.
Yeah.
Okay, it's done. After that, you need to filter how you need this image. In this time, you need to define. Suppose in this time I need this image less than 1% cloud cover. Okay, I need this image. Suppose you need this image for less than 1% cloud cover. So this is your choose. You need the image less than 1% cloud cover because I need the very clear image. Okay. So in this time, for this, I simply use a function. This function called the filter metadata. Okay. And when you write the correct spelling of the function, we can get this type of purple color. Okay. Suppose you can just put the same spelling, also use the camel case, you get the result as a purple color. Okay. Suppose in this time I just put here the, you can see it is a uppercase M, but I put here the lowercase m. You can see it's not a purple color. It shows as a this type of black color or font black color. Yeah. Okay. But when you write the
purple, so it will be right.
Yeah. When you can see I put here the right function, it shows as a purple color. You can see purple color. There is a no mistake. But when you put any uppercase or lowercase mistake or any spelling mistake of the function, it shows as a black color. Okay, so this we can easily find out our wrong using this technique, filter metadata or other function, any function. When you miss any kinds of, suppose you can see O, it is a uppercase O, but when I put here the lowercase O, then it shows as this type of, you can see as a black font. So it's a problem. When I run the code, it not execute. So that's why use here the uppercase O. Now it shows as a purple color. Okay. So now filter metadata. So basically in this tab, I need the less than 1% cloud cover. So put here the filter metadata. So basically this function provide you the image less than 1% cloud cover. Okay. So basically this function we are used to get the result for find out the image properties. Okay. So what is the image properties? Image properties, here you can see in the image properties tab, here I found out the different types of image properties such as cloud cover land, different types of image properties we can get from here. So in this tab, I need the cloud cover. This is my image properties. Okay, cloud cover less than 1% I need. So for that, what can I do? Just I simply take here that I simply copy this properties name. You can see the cloud cover, simply copy and paste here and put here that less than, okay, and put here the 1. Okay, so now what happened? In this time, for this Qatar region, I choose only for those images, which image will be not more than 1% cloud cover. Okay, so filter bounds, filter metadata done. After that, we need to define when you need this image. Okay, so in this time, when you need this image, suppose you need this image for year of 2023. Okay, suppose year of 2023. So what can I do for that? Simply use a function, filter date function. Okay, in this time, you put here the start date and end date. Suppose year of 2023, 1st January from year of 2023. In this time, we can see what is the last date about that. This last date about that, we can get the 13 November. Okay? 13 November. This is our last time period. So just put here that November 13. Okay. So now here I can get this type of image. So you can say I filtered the image. Okay. So first of all, I filter where you need this image. You need this image is the Qatar. Okay, and I already created, you can see I already created the Qatar boundary shape file and stored it in this variable ROI. And then how you need this image? So you need this image less than 1% cloud cover. And then when you need this image year of 2023. Just put here the start time and end time. Is it okay?
Yes.
Okay. So now if we want to check how many emails I can got year of 2023, suppose you want
Yes.
to check how many images are available. Okay, in this time I simply print that. So print this variable. Okay, because all of those function, you can see all of those function only store it in this variable Lancet 8. Okay, simply copy that and paste here. Okay, and then use a function, size function. Mainly this size function calculate or computing how many images are available. So let's go. We can check how many images available. We can get the 46 images is available for this Kathar. Okay. We can get the total 46 images, satellite images of Landsat 8. 46 images we can get in here. So now from here, if you want to check about the time, suppose in this time, if you want, you can also work with the single time period image. Suppose you just choose only for a single date image. Suppose you can see here, image collection. You can see the feature. You can see the different time period we can get in the image. So here you can see different time period. You can see in this time. Suppose I just created the median image. Okay, not take the single date image. Okay, I just
I have
created.
here error also.
Okay, so let me check about that. Okay, so
Filter
okay,
bound.
just I simply stop the sharing. Okay, please increase that the font size. Yeah. So let me check. Yeah. So EMS collection filter bounds. There's the cloud cover. Let's
The error here.
okay. EMS collection is not defined. Okay, filter bounds. Okay, filter data. Okay, now go to the code. Okay. So in this time, Lancet image collection. So filter bounds. Okay. You made the mistake in the filter date function. You can see filter date is not show as a purple color. You put the data DATE. Okay, now check again. Okay, so it's very carefully when you write the code.
Yeah.
So you
It's very sensitive.
yeah. So that's why. So now it will work. Yeah. So now it's working. You can
Yeah.
see.
So now we have 46 images here.
Yeah. So now
Okay.
using the total 46 images, we just created the median image collection. Okay.
I
So in
see.
this time, we can get the only for the whole year. So all of those images we can consider and make the median image collection for 2023. Okay. So for that, what can we do? Suppose I need to create the median image collection or median image composite. So you can create the composite of median image using the total 46 images. Just use here the median. Okay, so just put the median. So now it will be work. So median. And finally, this median image just clip with your boundary. Okay, so just put here the clip function. Clip mainly it's just clipping with your boundary. And what is your boundary? Boundary means the Qatar, and Qatar is studied in the ROI. Okay, simply copy the ROI. Okay, so now in this time we are just show the layer of images. So put here the map dot add layer. And then I want to show the Landsat 8. So in this time, you can see all of those function is stored in the only for the one variable, Landsat 8. Simply copy that and paste here, click to the run. So now it visualize your image, you can see. For the year of 2023, we can get the image of the Qatar.
I add layer, right?
Yeah, map.add layer function, because in this time we add the another
Yeah,
layer
that's
for
it.
Landsat image.
The last one is
Yeah, you can see, yeah, map.add layer,
yeah.
then call your variable name. Okay, is it okay?
Yes.
In this time, we can get this type of image, you can see. It shows as a default visualization. So in this time, we add the visualization. So for that, simply click on here. And in this time, I simply add here, you can see red band. Okay. So this option you can find out, you can see the layer. Okay, layer.
And the layer.
Yeah,
Yes.
layer 2. Okay. Because layer 2
Yeah.
is stored the image, and layer 1 is the boundary, only boundary, and layer 2 is that image. Okay. So you can see the setting button, look like that button is a setting button. Click on here and add here the, you can see different types of band. Okay.
Yes.
So in this time, we can make the band combination such as red band, green band, and blue band, RGB. And you can see the custom is stress 98% for reflectance. So now apply. Now we can get this type of image, you can see. Okay.
Yes.
After applying, we can get this type of images. And this is the image for 2023. So this is my satellite images. And now we are use this image and then make Ndvi map of 2023.
Yes.
So did you get this map, this type of image?
Yes.
Okay.
Yes.
After getting this image, you can simply see the import button also, you can see import. Okay. In this time, simply click on the import button. Click on the import button and a new line of code added in your script, you can see. When I click the import, it added in my here. Simply copy that, simply copy and paste after the Landsat 8. This variable paste in here. Okay. So now it's set. Simply click the import. After that, simply copy this variable name.
Yes.
And paste in here. Okay, so now this visualization is set with my image. So in this time, you can click to the run. You can see it automatically set the visualization look like that.
Yeah.
So now it will, you can see we can get this type of image.
Perfect.
Okay, so now we can get this type of image in here. And now we can easily make the different types of remote sensing analysis.
I want to ask you one question.
Yeah,
here, when I
please.
make save, there is a message come to me.
Okay, so kindly increasing your screen. Yeah, so
this is what?
This cheese could not be applied because repository changed it last time. Loaded. You like to latest version repository over. Okay, you can click to the no.
No?
Yeah, click to the no.
Okay.
Okay, so now it's okay.
So it's fine. Okay. Thank you.
Okay, so now we can get these images look like that. And now we are just make the Ndvi map. You can see in this time it's called the natural color. Okay, so basically using the natural color we can get this type of visualization. Not only for the natural color, we are use here the different types of band combination from here. Suppose I use here the false
Yes.
color band combination such as near infrared, red, and blue. We can simply put it the near infrared. Then put here that suppose red, and put here the suppose blue. Stress 98%, and apply. So now I can get the another visualization of the satellite images. Okay. So basically in this time, from this satellite images, this type of red pixel value you can see. This type of red pixel value identify about the vegetation.
Yeah.
So basically when you use this type of band combination, near infrared, red, and blue, we can find out the vegetation as a red color pixel value. You can see it.
Mm.
It is a
Yeah.
vegetation or cropland, I think. So we can get this type of vegetation. You can see the vegetation about that. And it's not mass vegetation, just some cropland. Yeah, also you can see this is the vegetation. Is like in the way. As well as you can also use here the suppose another band combination is the suppose short wave infrared one. So mainly the V6. Then put here the near infrared, and then put here the red. This is another band combination where use also identify the vegetation or cropland. So in this time we can get the vegetation as this type of, you can see type of
Yeah.
color. Okay. And
Mm.
this type of is the barren land or sandy land about that. And water body show
Yeah.
as this type of black color water body. Okay. So
Yes.
mainly we are using
Yeah.
the different types of band combination to identify for the different types of feature on the surface.
Yeah.
Okay. So in this time we are just talk about the NDVI. So NDVI in this time I need to create the NDVI. So in this time here you can see the another thing is that in this time it shows as a layer 2. Okay. If you want, you can also set the name in here. So for setting the name, simply click comma sign and put here the suppose image. Suppose image 2023. Click to the run. In this time, this name is set as a layer name. In here you can see image 2023. Okay. So now we are just working with the image 2023 and then make the NDVI map. Okay. And first of all, here you can see already see the formula. Okay, in this time we are just put here this type of formula NDVI, mainly near infrared minus red divided by near infrared plus red, and then make the NDVI, and then also make the different types of classes. So mainly our main target is that we need to create this type of class: low, medium, high. So 0.2 to 0.3 is considered as the low, medium 0.3 to 0.4 is considered as a medium, and greater than all of those 0.4 we consider as a high. Then from that we can easily calculate the area as well as we can easily make. Okay, so let's go about that. Okay, so in this
We
time
don't have water, and in Qatar we don't have water feature.
no, in this time we are just take only for the vegetation. Water is that you can see
Yes.
water is the negative pixel value.
Minus.
Minus.
Yes.
Yeah. So it's the
Yeah.
water body. In this time we are show the change direction of the vegetation. So vegetation mainly it is start from the 0.2. Then we do that. So in this time we are just put here the this type of formula. So just I simply copy this formula and then paste in your code editor. So it is just I put the comment. Okay. So as a comment. So NDVI is that near infrared minus red divided by near infrared plus red. Then we can easily get the NDVI index or NDVI map or vegetation cover map. So in this time, here you can see, I just take a variable, suppose NDVI 2023. You can put any variable name. Then use the equal sign and call the this variable because Landsat 8, you can see what is the Landsat 8. Landsat 8, this is the Landsat 8 variable. This variable is stored in my image. Okay, all of those band, all of those things is stored in this variable Landsat 8. Simply copy that variable name and paste here and use a function. This function called the normalized difference. Okay, so you can see its function is the normalized difference. When you write the correct format, we can get the purple color. If you mistake any wrong spelling or other things, then it shows a black font. So in this time, this is my things I put here, the normalized difference. Okay. So now this function, mainly this function, calculate this type of equation. Okay. So when I put this normalized difference and put here the band name. Okay. Suppose in this time I put the band name is that near infrared. Near infrared is that B5. And then put at the red B4. Okay. So normalized difference between band 5 and band 4. Okay. Near infrared and red. So when I put here the normalized difference, then it automatically calculated band 5 minus band 4 divided by band 5 plus band 4. Okay. So when I use this type of function, normalized difference, it automatically calculated.
No need to add the function itself.
Yeah. Yeah. So it automatically calculated band 5 minus band 4 divided by band 5 plus band 4. Band 5 is the near, band 4 is the red. So you now it's calculated the Ndvi map. You can see I want to add a layer of Ndvi map. So use add the map.add layer and call the Ndvi 2023. Simply copy and paste. And then click the run. Okay, so what's the problem? Okay, in this time, we are mistaken here. You can see we have to make a list. Okay, so use at the square bracket and also put here the square bracket. Now click to the run. So now it's working. You can see it added the map of Ndvi. Another layer you can see, layer 3 is add.
Landsat. Oh, okay.
Okay.
Yeah, I put the Landsat 8 capital letter. That's why it's not working.
So now you can see you can get this map as a grayscale color. And we did not get the, in this time we add the color of Ndvi map. Okay. For adding the color, first of all, you can simply write the code in here, put the curly bracket and put at the mean value of Ndvi. Mean value of the Ndvi for this study area. So I don't know what is the mean value about the Ndvi. So for that, you can simply click on the layer. You can see the layer option, layer 3. You can get the setting button. Click on the setting.
Yes.
And you can see the custom. Increase the 98%. So now it show the value. Mean value is the negative 0.387. Simply copy the value and paste here. Mean value.
I have the front number here.
Yeah.
I have minus 370.
Yeah, no problem. You can put at the negative 0.3. So it's a value. So this value we can get for this study area. For the negative Ndvi value, it will be start from the, for this study area, 0.38 or something like that.
Yes.
Or if you want to take only for the two digit, no problem. Suppose 0.38.
Yeah.
And then put at the max value. So you can get the max value 0.48. So 0.48. Okay. And also put the color. Suppose you can put any color. Plated. So use at the PALE plated function and make the list of the color. So suppose I put the list about the color such as, suppose put at the blue color, suppose white color, suppose put at the, suppose green color. So then click to the run. In this time, this color is the set with my map of Ndvi.
Palette blue.
Yes. So now you can see the Ndvi map look like that. So we can get the vegetation. This type of green color identify about the vegetation. You can see it's the vegetation.
I have quite different color.
Okay, so let me check. Okay, so why you can get this type of color? Okay, simply increase that.
Maybe because of the value, minimum and maximum.
I'd also considered about that. I think, yeah, blue, white. Okay, click on here. I
Because
put the
mine.
98%. So custom as 98%. Click on the custom. Yeah, 98%. Yeah, now. Yeah, so now it's okay. You can see. We can
Yeah.
get the better. Okay, so now we can get the perfect result for this. Okay. Okay, we can. It's
Yeah.
an NDVI map year of 2023. We generate.
Yes.
So let's go. Okay, so in this time we can get this type of map of NDVI. So now
Yes.
from here, if you want to check the value, suppose click on the inspector tab, you can see the inspector. So basically
Yes.
this tab we are used to map querying result. Suppose inspector tab, click on here and click on your suppose this type of vegetation, click on here. In this time we can get the what is the pixel value of NDVI. You can see, yeah, we can get the 0.5. Okay, so it's a dense vegetation or cropland or cropland at is the pickup stage of the cropland status. Okay, so plantation, harvesting, and then so plantation, then pickup state and harvesting. So mainly in the planting time, we can get the low NDVI. Then when it will be increase the tree of the cropland, mainly pickup stage, we can get that highest value of the NDVI. And when it will be just harvest time, we can get the low NDVI value. Okay, then this time we can get the 0.5. Okay, so it's a pickup time of, okay, this you can see step of NDVI. Okay, so in this time we can also get the water body. You can see this type of water body as a blue color. You can see, click on the blue color, you can see, and also you can see it show as a ND. It show as a ND. If you want, you can also rename it. Suppose I put the name as a NDVI. So for that, you can simply put here that dot rename function. Rename as NDVI. Okay, just put here the dot rename NDVI. So now click the run again.
Wait again. After this one, okay. Dot rename only. NDVI. And then run. Okay.
Okay, so now you can simply click on here any map pixel value. Click on this map. Suppose click on here. In this way, we can get the name as a NDVI. It's the NDVI. Okay, we can get the name as NDVI. So now we are just make the classification of the ndvi. Okay, so in this time it's not a classification, we did not put any types of class. So in this time we are just make the classification of ndvi, and we are just apply this type of things: 0.2 to 0.3, 0.3 to 0.5, and greater than 0.5. Okay, so in this time we are just, if you want you can also change this type of range, there is no problem, because it's not a fixed about that. Suppose your study area we can get the 0.5, greater than 0.5 is not available, so then why you can simply change it as a 0.4, greater than 0.4, or greater than 0.3. So basically this type of range we are also considering for the different study area. We have to put the different value.
Yeah.
So let's go. Okay, just a minute, I have a important call. Just a minute.
Okay.
Okay, so let's go. Okay, can you hear me?
Yes.
Okay, so in this time we can get this type of things. So now we are just make the classification. Okay, so in this time our classification we are just need to make the result according to this range. So suppose 0.2 to 0.3, 0.2 to 0.3. We consider this is a low. 0.2 to 0.3. Then we take the another class, medium, 0.3 to 0.4, 0.3 to 0.4, and finally high, greater than 0.4. Okay, so all of those pixels greater than 0.4 we consider as a high NDVI. So now from here we are just at the port. So just I simply open my
0.4, which
yeah
is high.
yeah
But
0.
the medium will be between 0.3 and 0 high.
Yeah, so you can also we also change this type of value because it's not fixed for all of those region. Suppose when you want to work with for the forest region or dense vegetation region, so then this type of things will be also changed. So in this time for this study area,
This
suppose
is
you want,
only for desert.
yeah, suppose in this time for this you want to find out what is the maximum NDVI value for this study area. So for that I simply find out. Suppose I take a variable. Suppose I put the variable name is the max NDVI. Okay, and then call my map. So NDVI 2003 simply call and paste here and use the function reduce region. Okay, reduce region you can simply put in here and put all of those argument one by one. And how we can get this type of argument? Simply press a control and forward slash. So this is the control button, control plus your this symbol. Okay, any function. Suppose you can see again how I can write that. Simply write this function, any function, simply write. Suppose you can see, suppose I write again the function, suppose reduce region. Okay, and in
Anywhere?
this time you can see now simply press control and space. Okay, control and space. Sorry,
Wait,
it's space.
I will try.
Control and space. Okay, control and space. We can get all of those argument. Okay,
Control and space.
space.
Nothing happened for me.
Okay.
I'll
So
try
now
again.
we can get this type of things from here and now make a dictionary. So curly bracket start and also in the dictionary. So curly bracket
Can
end it here.
I only type this one or no? Because I'm using Mac laptop.
Okay, so in the Mac you can find out the control button and space on your keyboard. Okay, control and space. Suppose any function you can write.
Doesn't
After that, press control and space. It
It
provides all
doesn't
of those.
work.
Okay, now from here, after that, simply suppose reducer. You can simply put a reducer maximum. So EE dot reducer dot max. Okay, geometry is the boundary area. The boundary area is that ROI because Qatar ROI. I already defined the geometry Qatar. Scale is the resolution 30 meter. Put here the 30. And it's not
Wait,
assembly that it
I
assembly
think
it's not it.
I
Or if
couldn't have this one. It's fine, right?
yes,
Can you see my
yeah. So simply
screen?
increase your screen.
Here it's right.
Okay, also increase it not focus. Yes, now perfect. Yeah. Yeah, reduce region. Yeah. So now press control and space on your keyboard.
together.
Okay. Another thing is that you can see you use here the hyphen. Max NDVI, you use the hyphen. Okay, in the variable name, we are not use the hyphen. We can use here the underscore. Okay, put it, yeah. So now go to the function reduce region in the middle of the cursor, yeah. Then press
Control.
and space. And you can, okay, so I think you control and space. Put.
It doesn't work.
Okay, so did you use the second bracket or first bracket? We have to use at the first bracket, yeah. So simply
Here?
remove first parenthesis use in here, not second. Okay, remove the bracket and put at the first parenthesis. Yeah. Put it the first parenthesis. Put.
This one?
No.
This one?
No. The second. So okay, so put this one. First bracket.
Normal. This one?
Yeah. Normal. Not yeah. Then put the control and space.
Control and space.
Yeah.
It's not working.
So why it not working?
I don't know. Control command doesn't work also.
Okay, I think something. Okay, so for the Mac is another system or not? Yeah.
Oh, maybe. Can you just copy it for me? I will
Yeah,
take
no
it
problem.
here from
Yeah. So I simply copy.
I will see if I can walk it, if I can make it. Where can I go
Copy.
to the chat pad?
I send you. So yeah. So now simply copy that and paste here.
Okay, but here I will add not ROI QAT because I built it QAT. Wait, it's Arabic. QJR. And then I make run.
Yeah. And okay, so now it's okay. And after that, just use at the print function. You can say I simply use at the print function. Also, I simply share my screen.
Yeah.
Okay, so just use the function print. Print this variable name max ndvi. Simply copy and paste and click to the run. So you can see the console tab. Console. Click on the console. Okay. In this time, we can get this type of problem. You can see too many pixel in the region because it is a big region. So that's why there's a lot of pixel value. So that's why we have to mention about the max pixel value. Okay. So simply copy the max pixel and write here max pixel and set the value as a 1E13. Okay, then click the run again. I hope now it will work. We can get the result. What is the maximum NDVI value for your study area? Okay, so now you can see the object 0.6. Okay, did you get this type of value?
I'm trying to make it. There is max pixel.
Yeah, MAX, P is uppercase. Okay, max pixels.
Yeah, and then LE or 1.
1E13.
1E13. Then there is an error.
Okay, so let me check what's the error. Okay, so increase that.
Sorry.
Okay. Max. Okay. In this time, yeah. So in this time, you can see the 30 bracket, parenthesis, second bracket, simply remove. Remove. Yeah, remove. And use the comma sign. Comma. And now work. Click to the run. Okay, so go to kindly increase. You can get the sum wrong.
Max and Ndvi print.
Kindly increase that size, font size. Max. What's the problem? Max and if it's the okay, no problem. Print.
There is no error.
Okay, so in this
Let's
time,
see
okay,
here.
you can see the what is the error, the right.
Reduce region.
Okay, so remove the reduced region. You can see the yeah. So it's not need. Simply remove that yeah. So now try. So now it will work. Simply click on the object. Okay, we can get the click on the object. You can see the object in the console tab. Console tab, we can get the object.
Yeah.
We can get the maximum NDVI. What is that?
6.
Yeah. So this is the maximum NDVI value for the 0.6 for your study area. Okay, so now we are just make the classify. Okay, so let's go my screen. So just I simply share my screen.
Yes.
Okay. So now this is my map. I generate NDVI map, and now this map I just make the classification into 3 class: low, medium, and high vegetation. Okay.
Yes.
So for that, I have to use a function. This function I simply write in here. Suppose I put the variable name is that NDVI class, suppose 2023. Okay, you use here the underscore, not put the hyphen. Okay, hyphen when you put, then it will be make the 2 word. So 2 word without space we can use only for the variable. Okay, so in this time just use the underscore, it's better. Okay.
Yes.
So now I just make the class low, medium, high. So for that I use here ee dot image. Okay, ee dot image, and then put here the 1. Okay, after that in this time we set the some condition dot where in this time I consider the 0.2 to 0.3. So in this time I just put here that this I call my NDVI map. You can see, so this is my NDVI map 2023. Okay, so this is the NDVI map 2000. Simply copy the 2023 and paste here. And I want to show the result. Suppose 0.3. So put here that greater than GT, greater than 0.2, and use here the AND function, and Ndvi less than, suppose less than equal 0.3. Okay, I set my condition. So Ndvi greater than 0.2, mainly this is the 0.2, and get less than equal 0.3. So this range I consider as a low of Ndvi. Okay, suppose I put here that, suppose 2. Okay, just put the 2. Then put the another condition. So put here the higher and call the Ndvi. In this time, I put the Ndvi greater than 0.3 and Ndvi less than equal 0.4. I put the another class, suppose 3. And finally, I want to show the another class. Put here the higher Ndvi greater than 0.4. So all of those. I make the another class, suppose 4. Okay, so now this is my, I just create this type of classes. So I put the condition Ndvi 0.2 to 0.3, one class, 0.4 to 0. Okay, so 0. Okay, so it's some mistake. So it is 0.3 to 0.4, another class, and greater than 0.4, another class. Okay, so now display this map of class of Ndvi year of 2023. Use here the map dot add layer and call the Ndvi class 2023 and paste here, and it's clip with your study area, mainly is that RY or boundary. Okay, then put here mean. It will be start from 1 and max minimum 4. I set the platelet of the different color. So now first of all, I simply try to run the code, and then there the color. Suppose click to the run, you can check what is the class we can get.
Ndvi class.
Okay, we can get this type of class. So in this time, I saw the color.
I have error here.
Okay, let me check. Okay, so simply open.
Immediate is not a function.
Simply increase. Okay, so okay, so ee.image 1 where Ndvi greater than 0.2 and Ndvi less than 0.3, another class higher. What's the problem? Show that. Okay,
It's not a function.
Okay, so in this time you make the spelling, I think. Simply go to the function. Okay, in this time, I is the uppercase. I is the uppercase.
It's like this?
No, not here. In the your function ee.image, ee.i uppercase. So in this time, you can see when I put here that I uppercase, we can get the bold purple color.
Oh, right.
Bold purple color. Okay. So this is another function ee.image. And now click run.
Okay.
Okay, so now let's check the color. Suppose I put the color is that total 4 color need to add. Suppose I put here that one is that suppose put here that what's color suppose.
Can you share your screen?
Suppose I put here the blue color and then put here that for that sparse vegetation. Okay, so you can use suppose I can simply search here. Suppose light green color hexacode. So now it provide this type of color code. I simply copy from here. Light green color hexacode, and then paste here. So after that, a medium. I want to show the medium is that light green. I put here the only for the green. So green color hexacode. Simply copy this hexacode.
I will print it from your.
And for the I vegetation, I show as a suppose dark green color hexacode.
You put
Simply search on the Google, you can get this type of hexacode.
dark green.
Okay, just simply copy from here.
Can you show me your coding GEE? Yes.
Then make a list
Blue.
square bracket.
Wait. Okay. 9. So you remove the blue.
Yeah.
It's the same number, the last two. You have green and then another green.
Yeah. Going to check off. Simply copy. That's how you can get this type of result. Now we can get the variation.
0, 1, 3, 2, 1, 3, 2, 2, 0. And then run directly. No, add map layer. Oh, this is already the add. Okay. Oh, there is an error. Which is the error? Okay. Now it's fine. Oh, again.
Did you get this?
I have error. Image visualization color is not valid. CSS color red or red found. Can you see?
That's right, yeah. Simply stop the sharing. So increase that. Yeah. Okay, so plate it. What's the problem showing that? Okay, so invalid image relevance color is not valid. CS33 color. Okay, so some problem in the color code, I think. So simply, okay, just I copy the code and send you. Try to use the same and check.
Okay.
Try to use that.
So now it's working.
Yeah.
Yeah. So I have this.
Okay, so now I simply share my screen.
The color here, right?
Okay, so now can you see my screen? Okay, so just I run the code again. It's loaded. Here we can get the total 4 class. You can see 1, 2, 3, and 4. So now what is the 1? So mainly 1 without all of those range. Suppose 0.2 to 0.3, 0.3 to 0.4, greater than 0.4. Without all of those pixel, including in the number 1 class. Okay. So it also including the water also. But our main concern is only about this class. It loaded. I think some networking issue.